Hello everybody. In this video I'm going to be talking about the area of a triangle. In the last video we talked about how the area of a parallelogram and the area of a rectangle were very similar. In fact, they were pretty much exactly the same. We said how we don't really need this because the length and width can just be called the base and height, and so we can actually get rid of all these and just use the letters from parallelogram. And the reason I'm doing it this way is to show you that the formula for all three of these shapes is actually almost the exact same thing. The formula for area of a triangle is actually area equals base times height. The only difference is we're going to divide it by 2. Okay, so it's the exact same thing as these two. We're just going to divide it by 2. So why is that? Why are we just going to divide it by 2? Well, if we take this parallelogram here and divide it in half, or divide it by 2, we're going to get, that's right, 2 triangles. The same thing is true for this rectangle. If I divide it by 2, I get 2 triangles. So all a triangle is half of a parallelogram. With the height being measured the same way a parallelogram height would be measured, at a 90-degree angle off of the base. Okay, so in this case, this height here is 90-degree angle off the base. This height, 90-degree angle off the base. This height, 90-degree angle off the base. Same thing. So let me show you a few different types of triangle shapes. So we have this one here. Notice we have a height coming 90 degrees off the base. We have a right triangle in the middle here. We don't need a dotted line because in a right triangle this angle is 90 degrees already, so we know that this is going to be the height and this is going to be the base, and here we know this is going to be the base and that's going to be the height, and here we know that this is going to be the height and this is going to be the base. Similar to the parallelogram where we needed an imaginary line to get a 90-degree angle to measure the height, same thing with this triangle. We need this imaginary line because nothing in the middle here would get quite high enough to reach that opposite vertex from the base that we need to get the full measurement of the height there. So just to show you how each of these can be a parallelogram, I'm going to clone each of these guys here and show you how each of them is a parallelogram. So here we go. I'm just going to flip this guy over. It's not quite right. Let's do that. Oh, there we go. So there's a parallelogram. Flip this one over. There we go. That one is a parallelogram. This one is actually a rectangular parallelogram because a rectangle is basically a parallelogram with 90-degree angles. And this one, whoa, getting a little crazy here. Well, that's going to be a little harder to get in there, but I assure you it is, there we go, a parallelogram. And so, let me just move these down. So we have all these triangles here. And we want to make sure that when you're using the area formula, which, as you just saw, is area equals base times height divided by 2, some people call it 1/2 times base times height, which is the same thing. Notice that the height always has to come 90 degrees off the base. It's pretty simple to see here. The base is on the bottom, the height goes up from there. Base is on the bottom, height goes up from there. Base is on the bottom, height goes up from there. Well, in this case, which one is the base? Well, truthfully, any one of these sides could be the base, but you got to make sure you have a height coming 90 degrees off it. So in this case, the top side is actually going to be called the base, and this is the height. Here we could call this the base and this the height. And then in this case, we have this base and this height over here. Now, with a right triangle, either one of these sides that come off the 90-degree angle could be the base or the height. Let me show you an example of that. Just kind of move these out of the way for a moment. Okay, so let's say the height in this case was 4, and the base in this case is 6. And down here, I'm going to switch it up. Let's pretend that I made this the height and this the base. So in this case, the height would be 6 and the base would be 4. Well, using the formula, I would get base times height, which is 24, divided by 2, and I would get 12 square units. Over here, I would do base times height. I would still get 24 divided by 2, which is still 12 square units. So in a right triangle, it doesn't matter which one is the base and which one is the height, as long as you're using the two sides that go off of the 90-degree angle. One thing we need to talk about over on this triangle, because it can be kind of tricky, is how we measure the base. The height is pretty obvious. You have to come in with this imaginary line here and make that the height. But the base, a lot of people get confused as to what to put on the base. So I'm going to put in a few numbers here, and we're just going to talk about which thing is which. So let's say this is 4 and 3 and 5 maybe, and we'll call this 6, and this will be 7. So there's like 5 different things we could label here. Only two of them are necessary, and the other 3 are flat out wrong. So we have area equals base times height divided by 2. The 5 is a trick. That is off a diagonal. We can't use that. Same with the 7. We can't use that. The base actually is going to be this here, the 6. Okay, so it equals 6. The height is the 4. Whoops. Let's move that up. The height is the 4, and then we're going to divide by 2. Do not use this. So it's only the 4 and the 6. So the fact that I use 4 and 6 and the areas keep coming out to 12, that was just because I used the same numbers. I assure you, not every triangle has an area of 12. But one mistake that a lot of students make at this level is they think, well, I'm extending this line and that looks like it's part of the base, so I'm going to make the base 9, 6 plus 3. Don't do that. The 3 is not part of the base. We get rid of that entirely. The base is just the part of the triangle. Okay, the height is the only thing that can come off the imaginary line there. All right, and that's it for area of triangles. Thanks for watching.